Alright, so today we're going to be doing 10.3, which is going to be doing the unit circle notes. So let's talk about what a unit circle is. A unit circle is a circle with a radius of 1 centered at the origin, so 0, 0, of a rectangular coordinate system. So the rectangular coordinate system is the normal coordinate system you're used to using. X and Y, up, down, left, right, 1 unit, all of that. So a circle with a radius of 1 is going to be out 1 to the right, 1 up, 1 to the left, and so on. Okay? So how that situation works is basically you have a circle with a radius of 1. We have these points on the sides, and then we can take a point on the side of the circle, and of course we connect that point from that to the origin, and it's going to be 1. Does everybody understand why this length is 1 right here, the red line? Okay. So if this is a circle with radius of 1, that means that anytime you connect a point from the side of the circle, that length is 1, because it's a radius. Okay? So that's why it's 1. That being said, we know that this is some point x comma y. We don't know what point it is, but we know it's x comma y. So we know that the distance here, the horizontal distance, x, okay, is x, and the vertical distance is y. So that's where we get those things from. So, using the diagram to the left and SOHCAHTOA, we can define sine, cosine, and tangent functions for theta as follows. So we know that sine is what over what? Good. In this case, opposite is y, and the hypotenuse is 1. And cosine is what over what? Good. And we know that tangent is what? Good. Opposite over adjacent, or y over x. Now, we can simplify this down, right? So y over 1 is just what? And x over 1 is just? Good. So with that information, we know that a normal coordinate is x comma y, right? But now we see that x is actually equal to what? Is equal to cosine, isn't it? See how cosine is x, x is cosine? So x is actually equal to cosine of theta. And y is actually equal to what?
Sin.
Yes, sine, yeah.
Why is it sin?
Why is it sine, or why is it, is that what you asked?
Why is it sin?
Oh, sure. Whatever helps you remember. So is everyone good with how I got that, like from the picture? Okay. So in that case, if tangent is y over x, that means that tangent is sine of theta divided by cosine of theta, isn't it? And that's true. If you take sine of any value and then cosine of the same value and divide that, you would get tangent of whatever that value is. So tangent is equal to sine divided by cosine of any angle measure this works for. So does anybody have any questions about relating the sine to the coordinates? All right.
Is it only for circles? Like, does that only apply to circles?
It actually applies for every single sine and cosine relationship, which is derived from the circle. But yes, it applies to everything. This is a standard mathematical rule.
So why is sine and cosine the answer for the coordinate of x and y?
Sine is equal to y, cosine is equal to x, so I'm just subbing in. If x, we know coordinates x comma y.
Okay.
So, constructing a unit circle can be easily accomplished with the knowledge of 2 special right triangles, 2-degree radian conversions, and the xy coordinate relationship. So these are our special triangles. All right, everybody remember these? So the opposite side of 30 is going to be 1. So the side opposite the 60 is radical 3. And does anybody remember what the side opposite the hypotenuse is? 2. Now moving on over here, we have the side opposite 45, and a 45 which is 1. The side opposite the other 45 is 1. And does anybody remember what the hypotenuse is here? Good, radical 2. So these 2 triangles basically are the backbone to the unit circle. And I'll talk about how that works a little bit. But with the unit circle, we're going to talk about why it works for a few examples, and then I'm just going to go through and tell you what the rules are, because otherwise we'll be here literally all day. So
those measurements, is that for every right triangle and every
no, just a 30, 60, 90 and a 45, 45, 90.
Okay, but for the 36, 90 and 45, 45, that's the standard measurements?
These are just the measurements if the radius is 1.
Okay.
So now we'll talk about degree to radian conversion, which was our whole last lesson, right? From degree to radian. These are two standard ones that we deal with a lot. So 30 degrees is equal to the radian pi over 6, and 45 degrees is equal to the radian pi over 4. All right? So those are just some standard ones. We had a whole lesson yesterday about conversion. So if you're still confused about conversion, I'm not going to be spending too much time on converting this lesson, or it'll take too long. So if you have those questions, go back and reference my 10-2 video. We talk all about it there. So I'm going to be kind of doing conversions very quickly in this lesson, so I'm just going to let you know. Yeah, because there's going to be a lot of them. So, constructing the unit circle. So, the unit circle is basically a circle where all these triangles are inscribed, okay, and we have these different angle measures, all right? So, these angle measures are 30, 45, 60, and so on. So, we're going to talk about first converting all of these to radians. So, we're going to write their radian measures. And then after we get this unit circle done, this is for your reference. You're going to always use this as a reference, okay? So, first thing we're going to look at is, does anybody remember what I said 360 is equal to in radians? 2 pi. Remember that? And does anybody remember, so if 360 is 2 pi, then 180, which is half of that, is what? Just pi. And we know that 90 is half of 180, so what would that be? Pi over? Pi over 2, correct. Now, we know that 270 is the sum of 180 and 90. So what's 1 plus 1/2? 1.5, which can be represented as a fraction as 3 over 2, right? So it's going to be 3 pi over 2. All right.
Over 2, not 2 pi.
Why is this one 3 pi over 2?
No, like, why is it like 3 pi, not 3 pi over 2 pi?
Oh, because we're only taking this and adding them together. So, like, in reality.
Oh, it's pi over 1. Okay.
Yeah, it'd be pi over 1. Yeah, exactly. So yeah, that's 3 pi over 2. Now we're going to go in and do these other ones. So earlier I referenced on the sheet before that 30 degrees is pi over 6. Everybody remember that? And we can convert it, do our standard conversion. And 45 is pi over 4. And then I'm also going to tell you that 60 is pi over 3 because it's 1/3 of 180, which makes sense, pi divided by 3. So now we can use these main ones to get the rest of them. And I'm going to show you a trick to do this. So you see unfortunately we're not able to print your notes in color, but does everybody see the colors on mine? The different colors? These actually correspond to each other, okay? So what's the relationship between 30 degrees and 150 degrees? It's 30 times what? 5. So what we can do is we can take this radian measure and multiply it by 5, which actually gives us 5 pi over 6. So because it's exactly 5 times 30, we can multiply it by 5. Does everybody understand how we do that? So now we can do the same thing for the red ones. So 45 times what is 135? 3. So we can take this one and multiply it by 3, which gives me 3 pi over 4. Now moving on, we can then do the same thing for 60. So to get from 60 to 120, we can multiply by what? 2. So we're going to multiply our radians by 2 as well. So these are just, like I said, degree to radian conversions, but made simple. Now we'll move on to quadrant 3. So to get from 30 to 210, we multiply by what? 7. So I'm going to multiply this by 7. 7 pi over 6. To get from 40 to 225, we multiply by what? 5. So So that's going to be 5 times pi over 4, so 5 pi over 4. To get from 60 degrees to 240 degrees, we multiplied by what? 4. Good, so 4 pi over 3. And now we're going to do our fourth quadrant. To get from 30 to 330, we multiply by what? Not 10, but 1 up. Okay. 11. So 11 pi over 6. I take this one, multiplied it by 11. Oh, it did sound like this. Sorry. You both said 10, so I was like, maybe I did say it wrong. Good. So, to get from 60 to 300, we multiply by 5. So we take this and multiply it by 5, which is 5 pi over 3. And to get from 45 to 315, we multiply by
7.
Yeah. So 7 pi over 4. Does everybody see the pattern there? So these quadrants are mirrors of each other in certain ways. Okay, they have like a pattern that goes on. And that's kind of what I'm showing you, that pattern. Because otherwise it would take you so much longer to convert all of these by hand, like we learned in 10.2. So now we're going to move on to the coordinates of each of these. So this is where it's a little bit different. So I want to start with the basic ones, the horizontal and vertical ones. So if we're a unit circle, this means our middle point is 0, 0, and our radius is 1, so we're going out 1 unit. This has to be 1, 0, doesn't it? Because we went out 1. Is everybody good with how I got 1, 0? Now, if we're a unit circle and we have a radius of 1, that means this is going to be what? 0, 1. We went up 1 unit. And same thing to the left here. This will be negative 1, 0, because you're going out to the left. And what's this one on the bottom going to be? Good, 0, negative 1. So now for the rest of these, I want to remind you of something we learned on the previous page. We learned that a coordinate, x, y, can also be represented in the form cosine of theta, sine of theta. Okay? Does everybody remember that? Bathroom? Yeah, go ahead. So, with that being said, we are going to fill out the rest of our unit circle. So, with that, I'm going to be using that table that I talked about from 10.1. So that's what I'm going to be referencing right now, the table from 10.1 on the second page in the notes. So, the x-coordinate corresponds to cosine or sine? Cosine. So what's cosine of 30 according to your chart? I should probably get my chart out as well. I do have most of them memorized, but.
So wait, x and y always refer to cosine and sine?
Yeah, I mean they can depending on the context. In this case, yes. So like x is cosine of theta, y is sine of theta.
Okay, but it's not like this for everything, right?
I mean it is, but like it's not like you're going to use it every time. You know what I mean?
Okay.
So, good. So, cosine of 30 is radical 3 over 2. This is from your chart, from your 10.1 notes. Okay? What is sine of 30? 1/2, thank you. Now, the next one we're going to be doing is 45 degrees. So, what is cosine of 45 degrees? Good. And that means sine of 45 is what? Also radical 2 over 2. Those are always the same. Now we're going to, this is just like directly me copying from the chart, that's all. 60 degrees, what's cosine of 60? Good. And sine of 60? Good. So that's the main idea. Those are values we got right from our chart, and we learned about how we got those using the special triangles. So these are what we call exact values. Your calculator will give you this in the form of a decimal, but never in the exact value form. So now that we have that, all of these other quadrants are just reflections of that with different signs. So if you think about the first quadrant, the x-coordinate is positive and the y-coordinate is positive, right? But what about in the second quadrant? What happens to your coordinates? It's, yeah, your x is negative and your y is positive, right? What about in the third quadrant? Both negative. And what about in the fourth quadrant? Good, positive then negative. So now, how that's going to work is these are going to be the same values all around. They're corresponding, so like the 30 is going to correspond to the 150 and so on, but the signs are going to change based on the quadrant that they're in and what the rules of that quadrant are. So, with that being said, I'm going to correspond all of my coordinates over now. So, if I'm in the second quadrant, 30 degrees is equivalent to the 150 over here, okay? So, it's going to take the same coordinates, but instead my x value is now negative. So it takes the same coordinates as my 30, but my x is now negative. So does everybody see what happened there? So my 45 corresponds to my 135, it's its reference angle. So the same thing here, but now my x coordinate is negative. And then the same idea for 120, that corresponds to 60, but the x coordinate is negative. Not the y. I don't know why I put that. There we go. So is everybody good with that? All right. So now we're going to do the same process down here, but now what's the difference? They're both going to be negative. So 210 corresponds to 30. So then it's going to be negative radical 3 over 2, negative 1/2. 45 corresponds with 225. So these are both going to be negative. And then 240 corresponds with 60. So they are both going to be negative. So is everybody with me so far on that? All right, moving on. So now this quadrant, the x is going to be positive, the y is going to be negative. So 300 corresponds with 60, so it's going to be the same coordinates, but instead my x is positive, but my y is negative. My 315 corresponds with 45, my x is positive, my y is negative. And then 330 corresponds with 300, my x is positive, my y is negative. So this is what we call the unit circle. Now if you just Google unit circle, this is going to come up with all of it filled in for you. So this is like a standard thing. Alright, this is just like a standard concept, but I just want to explain how it works to you. Like we're going to fill it out ourselves, explain it, all of that. So is everybody good with the unit circle relationship so far? What? Fantastic. Even better. Alright. So now we're going to talk about signs of trigonometric functions. So just...
I'm sorry, could you go back to like 1 second?
Yeah. Alright. So now we're going to talk about signs of trigonometric functions. So basically, you know how each quadrant has rules, what's positive, what's negative? That actually corresponds to the trig functions as well. So the positive and negative signs of a trigonometric function and its reciprocal trigonometric function is determined by the quadrant in which the terminal side lies. So basically sine and then its reciprocal, they always go together. Okay, so its reciprocal follows its original. Okay, it's like a follower. So each quadrant has rules. Now in the first quadrant, everything is positive. Sine is positive, cosine is positive, and tangent is positive. Now I'm not writing out the reciprocals, they just always follow the original, so just keep that in mind. So this is the acronym all students take. You can either say courses or calculus. So the first quadrant, all of them are positive. The second quadrant, only sine is positive. So sine is positive, but the rest of them are negative. So the next one is the third quadrant, and the only one positive there is tangent. So sine is negative, cosine is negative, but tangent is positive. And in quadrant 4, sine is negative, cosine is positive, but tangent is negative. So this is more of a high level thing. I'm going to pause right here and just explain something real quick in case anybody is wondering why. So if you're curious to why it is the way it is, that's because in the first quadrant you don't have any negative values at all. It's not possible because everything's positive. In the second quadrant, cosine is negative because it's the x-coordinate, which is negative. Sine is positive because it corresponds with the y-coordinate, which is still positive there. Now in the third quadrant, both cosine and sine are negative. But the reason that tangent is positive is because we learned over here that tangent is the quotient of sine and cosine. What's a negative divided by a negative? Positive, which is why tangent is positive in the third quadrant. And then lastly, the reason that cosine is positive down here is because cosine corresponds with the x-coordinate, which is positive here. The y-coordinate is negative, which is sine. So that's the reasoning behind it if you're curious, but you don't have to know that. I just kind of wanted to explain it to you if you're curious. So, with that being said, remember that each of their reciprocal functions follow the same rules. So now we're going to do some questions about what quadrant we fall in based on sine. So given the following, determine which quadrant the terminal side of theta lies. So if tangent of theta is greater than 0, it means that number cannot be what? Numbers that are less than 0 are what? Negative. So we know that this number is positive, right? So basically they're asking you, when is tangent positive? In what quadrants? So what quadrants is tangent positive in? Good. Quadrant 1 and quadrant 3. So we can narrow it down to those two. And to be a little bit more like proper, you can write it as 1 and 3, but usually it's written as Q1, comma, Q3, okay? Quadrant 3 and quadrant 1. Now moving on to the next one, this is secant. We know that secant is the reciprocal of what trig function? Cosine. So this always...
That's what the terminal side means?
Oh, this is just talking about, like, that's what we call that angle, yes. The angle that's inside. We're just determining if that angle will be positive or negative, the measure.
Okay.
Yeah, don't harp too much about this. This is just, like, jargon, like, terminology that they use.
So, could you re-explain A? So why is it Q1 and Q3?
Oh, because see how right here in quadrant 1 and 3, see how tangent is positive?
Mm-hmm.
That's all.
Oh, okay. So for that, it's basically just saying in what quadrants is tangent positive?
Correct. So this one here is secant, which corresponds with cosine. Okay, see how secant and cosine correspond with each other. So this one is saying where is secant negative because less than 0. So basically they're asking you where is cosine negative. What two quadrants is cosine negative in? Good, 2 and 3. So remember the reciprocal follows its original, always. Now moving on to the next one, where is sine positive? Good, 1 and 2. And the last one we have to do it two-step. It's a two-stepper. So we're going to do each part separately. Where is cosine negative? Good. And cotan follows what? Tangent. So where is tangent positive? So which one of those do those two have in common? Good. So that when both of them can happen is quadrant 3. So the only way that they're both, that cosine is negative but tangent is positive is Q3. So does everybody understand that? You have to like merge them together. So these are like a really classic type of question that you're going to be asked in trigonometry class. So does anybody have any questions? All right. So now we're going to be moving into reference angles. So using reference angles to find trig functions. So first thing you have to do is identify the reference angle. So you have to identify what quadrant it falls in. That will determine the sign and the rule that you use. Then you use that exact value chart that I showed you from 10.1. So I'll talk you through all the steps, don't worry. So, you remember the rule that I taught you about earlier? I taught you about it a few days ago. And it's all written out again over here as well. But the rule is basically the quadrant rule. Oops. Sorry, this thing is hard to work with sometimes. So we have a coordinate plane. We have our first, second, third, and fourth quadrant. Remember the rule I taught you that the angle is just the angle in the first quadrant. Second quadrant is 180 minus the angle. Third is angle minus 180. And then fourth is 360 minus the angle. Do you guys remember this? So these are the rules that I'm talking about we're going to be using, okay? Determining what quadrant it falls in, what rule to use, but we're also adding in the sign now. So, first thing we're going to do is look at what they're asking and determine what quadrant it falls in. So does anybody know what quadrant 150 falls in?
Isn't it quadrant 2?
Quadrant 2, good. So does everybody understand why that's quadrant 2? Now with that being said, it's sine. So what's the sign of sine in quadrant 2? According to your last chart. Sine is what in quadrant 2? Positive. So quadrant 2 and positive. That's what we know so far. Now that we've determined what quadrant it is, what sign it is, we now know what rule to use. So we're in quadrant 2, this is the rule we're going to use. So we take 180 and we subtract away our angle, which ultimately leaves us with what? 30 degrees. Now you have to take sine of whatever that angle is, so sine of 30. And that's why that chart from 10.1 is so handy. Sine of 30 from your chart is 1/2. So the answer here is 1/2. And the sign of it is positive because we determined that sine in that quadrant is positive. So is everybody good with that procedure that we just did? Okay. It's not bad, right? So the next one here, tangent of 300. What quadrant are we in? Good. In that quadrant, what is tangent? Positive or negative? Good. Now that we've done that, we determine the rule that we're going to use, which is 360 minus the angle. 360 minus the angle, which leaves me with what? 60 degrees. We have to take tangent of 60. So from your chart, what is tangent of 60? Anybody know? Radical 3. Good. But the sign of it is what? Negative, because earlier we determined it's negative. You understand the procedure? Okay. Next one. Cotangent of 315. So, first, what quadrant are we in? Good. In that quadrant, is cotangent positive or negative? It follows the same rules as tangent. Negative. We use our reference angle. 360 minus the angle is equal to what? 45, right? Meaning we have to do cotangent of 45 from your chart, which is 1, isn't it, from your chart? Cotan of 45 from the chart is 1. But it's not, the answer isn't 1, it's actually what? Negative 1. So see that chart on your 10.1? Right here. So I just found cotangent of 45 is 1. So I just used this chart. I know. I was thinking about it like last night. I was laying in bed and I'm like, I probably should have put that chart on again on this notes. And then I was like, it was a lot. I'm like, where do we put everything? So the next one is secant of 240. So first we determine what quadrant is 240 in. Q3, right? And secant follows the rules of cosine. So what is secant in the third quadrant, positive or negative? Good. We do our reference angle, which is 240 minus 180, which is what? 60. So we have to take secant of 60, which according to your chart is what? 2, but the answer is actually negative 2. Alright, we have a few more to do, but the problem is these ones are not in degrees anymore, they're in what? Radians. So before we do anything, we have to convert them to degrees. So you can use the traditional conversion, or I'll show you a trick when they're in terms of pi. The trick is you just replace pi with 180, and that will convert it to degrees. So that's just like a little mathematical trick you can do. So I replace my pi with 180, and this converts me to 330 degrees. Now we can determine what quadrant we're in, which is what? 330 is in the fourth quadrant. In that quadrant, is cosine negative or positive? Positive. We use the reference angle rule, which is 360 minus angle, which comes out to be what? 30 degrees. We find cosine of 30 degrees, which is what? It's radical 3 over 2. Do I have to make it negative?
Wait, so for pi, you just filled in 180?
Yeah, this is just a trick on how to convert from radians to degrees. You can replace 180 or pi with 180. That's just like a trick, yeah.
Why can't you just use this big pie chart thing that we just did, since it's like the same?
You can, actually. The only one you can't use it for is tangent.
Why? Oh, because it's not.
Yes,
Okay.
but we do know that tangent is sine divided by cosine. So you can use the unit circle and do the sine of that divided by the cosine of that and also get the tangent.
Oh, okay. I didn't get that, but that'll be fine.
You what?
I didn't get a word you said.
Oh, I'm just saying, like, say you wanted to do, the problem is also secant and all of the inverse ones aren't
Yeah.
on there. But for sine and cosine, you can use it. And then if you take, like, say you want tangent of 30, you can do sine of 30 divided by cosine of 30, those two values,
Oh.
and it will give you tangent of 30.
Okay.
Does that make sense?
Yeah.
Okay. So the next one, cosecant of 7 pi over 4, we're going to convert it to degrees. So that's going to be 7 times 180 divided by 4. That's just how to convert it to degrees. So that's going to be 315. What quadrant does 315 fall in? Fourth quadrant. Cosecant is the reciprocal of what trig function? Sine. What is sine in the fourth quadrant? Negative. We use our reference angle rule, 360 minus 315, which is 45, which means we need to calculate cosecant of 45, which is radical 2, but the answer is ultimately what? Negative radical 2. So the last two we're going to look at. So secant of pi over 2, that's the same thing as secant of 90. Now you're going to notice that that is not on the chart, is it? But it is on the unit circle, right? 90. So go ahead and look at your unit circle. Now secant corresponds with what trig function?
Sine. I know. Cosine.
Cosine. What is cosine of 90? Anyone know? Cosine is the x-coordinate at 90.
0.
0. What's the reciprocal of 0? Can you have 0 in the denominator?
No.
This is undefined. So is everybody good with how we got that one? You sure? Okay. So you just have to look at the unit circle for the 90, 180, 270, and 360. So yeah. Anyways, let's try the next one. So this is sine of 7 pi over 6. We convert this to degrees. What'd you say?
210.
Thank you. So sine of 210. What quadrant is this? Q3. Sine is what in that quadrant? Negative. So that's 210 minus 180, which is 30. Sine of 30 is 1/2, which is ends up being negative 1/2. Which also you can see on your unit circle. You can see that 210, your sine, which is your your y coordinate, is negative 1/2. Does that kind of make sense? Okay. This is kind of a weird thing to introduce because it's so different.